Alright, first, we need to know what Earth-centered, Earth-fixed means. Okay? And this is the rundown of what it is. You can look it up yourself. It's a WGS84 datum. It's basically this right here. There's the ellipsoid. And so I can establish the latitude and longitude is here, and this is the prime meridian. Okay? So, let's see. And here's more of WGS84 coordinates. Earth-centered, Earth-fixed. Signals. L5. Not position and time. Signals. L1, L2. We use L5. Where the fuck's that? There's 5. Anyways, more of that. You can research it yourself. Anyways, here's my coordinates for, and it's in meters. So I got the top of the Washington Monument, the building. These are all buildings. And so then I got the ground of the Empire State Building, top floor, Sears Tower, and Philadelphia, the Liberty 1. So, remember my coordinates here. So, that's the point number, northern, eastern, elevation, description. So, here's my plan view of my drawing. Doesn't look like much, does it? But this sucker's pretty complicated, okay? So, because it's in 3D. It's X, Y, Z. That's why it's X, Y, Z. Okay. This is 2D. Looking straight down, top view. So, let's go to this. Alright, now we can see it. So, Right here's the Sears Tower. So that's the top. These are actually survey points. So I got my tool space, so I can come in here and points, edit points. And if I click on it, it's a Kogo point. So that's not some that's the real deal. So so how I drew this is first I had to get this. And I got for this here, because we're going. And that's that line to draw. So not the back to draw my ellipsoid. This guy right here. And so then it has those two numbers right here. So 635 minors 635 6752, and minors here is 635 6752. Okay, so once I established that, then we got this line, which is the prime meridian, or no, it's this one. That one is, because I got prime meridian. The layer is prime meridian, so yeah, that's the prime meridian, and that's all my measurements. All these measurements here. Remember all my measurements highlighted. Alright. And you guys want to know the tilt between the buildings, right? So, first we'll just evaluate some of this. So I got the top of the building. Now I got Sears feet. Pretty damn tall. And then when I got that, I extended it down to here. Okay. And then I can establish this line, the prime meridian, and then get my angles. So for like that one, I got 87 degrees. And I got, let's see, for the Sears Tower, 87, 63. 87, 63. I should have used 5.9, but I didn't. But thing is, when I did that one, then all the rest of them, they just came out whatever they were. So, we'll do Washington. So 77 degrees. Washington Monument. 77 degrees, 03. So I got 03, basically, if I round it, that 9 to a 3. And then if I do the latitude, which is this guy right here, for the Sears Tower. So I got 41, 87, 89. So 41, 87, 89. Okay. And go to the next one. Washington Monument. $38, $88. So 38, 88. Alright, now we'll go into check the distance. We'll open up Google Earth. Come on, bastard. So here's basically what I'm doing. I'm going from the Sears Tower. This is my alignment. Sears Tower to Washington to Philadelphia to New York. So that's what I'm doing right there. So what is that? Select that line. Properties. So properties, measurement. Make sure I got the right one. I'll turn it to red. Okay. So my measurement is 596. Okay. So my measurement between those two, come on, bastard. I got 595. 1 foot off. Whoa. Okay, we'll measure from Washington Monument right here to Philadelphia. It should be 123.92. So 124. So that's round it 124. And we'll go from there to New York. 83 miles. And I got when I did it, I'm like right on. So, that's the Empire State Building right there. You not see it? So, there's that. Now, I got the angles, the tilt angle between these. I think that's what you guys are crying about. So, fucking mouse making a lot of noise. Alright. And also, my north, this matches my latitude too. So 41 degrees, which one was that? 41, 87, 89. When I spin it, and they turn it to rendering realistic. How they're all pointing to the center of that. And you'll notice that the ellipsoid is wider this way, east and west, versus the north and south. So that's why if I zoom in, you'll see red. But if I tilt it and zoom in here, you see blue. And I got that because of the, like this is the sphere right here. So that's a perfect sphere, circle. That's the radius right there. So if I divide that by divide 5280. I got times it. Or yeah, it's in, goddamn it, it's in meters. I forget. So I can't do that. I'd have to. I'm trying to make this short as possible. So, anyways. Well, I'll just do it anyways, because you guys will bitch about it. Radius 5280, or we just do this radius. We'll go meters. Meters to feet or miles. So there you go. You want the diameter? We'll check it out what it is. So 79.17. I don't know if I use that number. Let's see here. Convert 79.17. Sure shit. Okay. So that's why I see that color red, because that's just a circle. So I erase that. Then I just got my ellipsoid, which is blue. So if I go there, now I just got my ellipsoid, which is okay. That's where we're at. So these things should be sticking out like little fucking needles. These buildings. See? Which they are. This was not easy to draw by no means. So here's my angles between them, the buildings. So if you look at this, right? You look at this, like look at the place. Bam, bam, bam. There's 3 here and there. And so there's 3 here and there. Same thing. Okay. So you guys want the angles between them. Okay. There's one. Really, shut up. And we'll just change that from 2 degrees. So 8 degrees. Okay. Between Sears Tower and here. Now we'll do from Washington to Philadelphia. Which is 1.79 degrees. And from there to New York, Empire State Building, 1.2 degrees. So there you have it. Now, let me see you guys do that. What I just did on Flat Earth. So, I don't think you guys can or know how. So I got the latitude, longitude, I got the distance, I got the building height, and I got the angles between them. And it's a goddamn globe. Okay? End of story. Peace out. 28 minutes.